Welcome back. In this lesson, we're going to look at calculating the area of circles and fractions of circles using the formula that I'll provide. And we're also going to look at calculating the arc length of given circles, and we'll talk about what that means. As always, if at any point during the video something isn't clear or doesn't make sense, pause the video, put your hand up or come over to speak to me, and I'll work through it with you. I'll just be sitting there twiddling my thumbs waiting for you to ask me a question, so please do. So last lesson we looked at this concept of pi, and we looked at the relationship between the circumference and the radius and the diameter, where the diameter is actually just twice the radius, and the circumference is the distance or the length around the outside of a circle. And our investigation found that there's this weird relationship where the ratio between the two happens to be this mysterious number, which we've deemed as pi. We can then use that for other things within circles. And in the case of an area, so the size that the circle takes up, the equation is the length times the width of the rectangle that basically makes it up. And there's a derivation video on YouTube which is really good, and it shows why we talk about rectangles and triangles. And we can think of a circle as lots and lots of really small triangles, and as that number gets smaller and smaller and smaller, we have tinier and tinier triangles. We get closer to this relationship where we have pi, our magic irrational number, times the width, which is the radius of the circle, times the length of the rectangle that we're talking about in this case, which is r again. They're both one and the same as it gets really small. So we resolve with this equation, the area is equal to pi r squared. And that is the area of a circle. So pi times the radius squared. And as we saw in indices, we know that this is just r times r. So this is really important. We'll use this a lot. This is the area of a circle. Next, we're going to look at how do we calculate the area for a partial circle. So if I take out a piece, it's like if I've got a pizza and I pull out a slice, I want to know what's the area of the remaining pizza. And this video is going to show how we derive that based on the fact that we use the area for a circle, and we just need to know what percentage of the circle or what ratio of the circle do we have, which is basically what amount of 360 degrees do we have. So this video will go through how we derive that. If I had a circle and then I've gone from the center and I've cut a piece out, and I wanted to know, well, what is the area of this shape? How much am I left with? Well, we know that the area of a circle, a full circle, is pi r squared. So if I have pi r squared for a full circle and I want to know how much have I got, well, we could think about how much of a circle have you got. If I took half a pizza or half a circle, straight down the middle, and this is what I've got, what would you say the area is? If a full circle is pi r squared, I've halved it, so it must just be half pi r squared. Then if I gave you a quarter of a circle, I've divided this circle by 4, you would probably say the area is equal to pi r squared divided by 4. So now if we go back to this original problem, I'm given a circle with a piece missing, and I want to know what is the area. Well, I know that it's some amount of the circle. So I could think about what is the total angle of a circle, for example. So if I do a full circle, that's 360 degrees. That's if I go from here all the way around back to the start. In this case, I've just gone from here to here. And I don't know how far that is, but I can call it theta, just some angle. So if I say this is how much of the circle you've got out of a full circle, and then I just times that by pi r squared, which is my full pizza, this is the equivalent of saying, well, if you had half a circle, that would be 180 degrees. 180 degrees divided by 360 is just a half. So I would get back to my half pi r squared. If I had a quarter, same thing, 90 degrees. It would give me 1 over 4 pi r squared over 4, like we saw earlier. So this is the general case. So the area of
A sector, which is what we call this, an incomplete circle, a piece of a circle, is theta, which is just how much of the circle we've got, over 360, and we times that by pi r squared, the area of our full circle.
Now we're going to look at something called arc length. An arc length is the length of the perimeter, but only over a certain point. So rather than doing a full lap of the outside, which is our circumference, we're just going from one point to another at a certain angle. And that's where the word arc comes in, because an arc is an angle traveling around a path. So an arc length is the length of the outer edge of the circle for a given angle. In order to do that, we know that 2 pi r is the circumference of the circle from before. So if the full circle circumference is 2 pi r, we just need to know, well, how much of that circle are we actually using? And that is just the ratio. So if 360 degrees is the entire circle, theta is the angle that you're given in the arc length, you just do theta divided by 360 and you times that by the circumference of the circle. For example, if you had a half circle, you know that you've got half of 360 degrees, so you've got 180 degrees. So 180 over 360 is a half. So you've just got a half of your circumference, which makes sense that if your circumference is the whole way around, you're only going halfway around, which would be an angle of 180, you would end up with half the circumference. So in these two examples, we show how we're going to do it. Find, rounded to one decimal place, the perimeter of a circle of 8 centimeters and a circle where the radius is 10 meters, but we've only got an arc length of 72 degrees. So in both cases, the circumference is nice and easy. We've seen that before. It's just a straightforward 2 pi r, where we've got 2 pi times 8 centimeters. We get 50.3 centimeters approximately, because remember, pi is irrational, so it's not an exact number. In terms of the perimeter, we know that it's going to be this arc length that we've just talked about, plus the radius, because we're talking a perimeter here, not an area. So we've got 2 times 10, which is 2 times our radius, because we go here and here, and then I add the length of my arc. And I've got 72 degrees out of the full 360, so that's my ratio. I times it by my 2, my pi, and my r, which is 10 meters again. So I get 32.6 meters approximately as my perimeter for this circle. Let's have a look at some practice questions. So here we've got finding the area to 2 decimal places, and then we've got, again, finding the diameter. We're given a diameter, we want to find the perimeter and the area of this circle. So these are kind of the worded versions of these questions. So answers will be up in 5 seconds. Pause the video now, have a go at these, and then answers will be revealed. Answers are below. Again, we've got some more problems. These are using slightly more complex shapes. Here we've got something completely different from a circle, which is what we saw in the previous chapter. We've got a pizza slice here with an angle. So again, we've got an arc length. Again, fractions of it. Our Pac-Man looking shape here. Half circles, full circles. Down here we get sort of composites. So we've taken out parts of circles. We've got a donut shape with a bit missing in the middle. We've got, again, like a rectangle with a triangle cut out, a straight triangle, and then almost like a football oval looking thing where we've got a rectangle with 2 half circles on the end. So have a go at these questions. Answers will be up in 5 seconds. Pause the video now and have a go at them. Solutions are below. Notice that in many of these cases, we're using approximates. Anytime we have a pi involved, it's going to be an approximate answer. Or if you've just written to 1 or 2 decimal places, depending on what the question says, that's sufficient. But we know that it's not exact because pi is irrational, so the number will just continue forever, unterminating. Now we're looking at perimeter. So using the concept of our circle shapes, some of these are very similar shapes to what we saw before. We've got our Pac-Man, our football oval, an ice cream cone, half a donut. But now we're looking at the perimeters of the shapes. So we're using circumferences and arc lengths to factor in how much have we got. So here again, we use the same concept. The key here is identifying that if we've got half a circle, the angle would be 180 degrees. And that's why they haven't given us an angle here. So again, pause the video, 5 seconds, the answers will be up, and then we'll move on. Solutions are below. That concludes our video on areas of circles and arc lengths. I'll see you next time.